Students, in previous video we have discussed the incident trace, how to act the incident trace on the concave mirror. There are three types of incident trace, which it means three rules. Okay, so the three types of incident trace, how to react and reflected on the concave mirror. Okay, so according to the three rules, we are going to discuss in this video the ray diagrams of the object situated in various places before the concave mirror on axis and characteristics of images. Okay, so కాన్కేవ్ మిర్రర్ ముందర మనం డిఫరెంట్ ప్లేసెస్లో ఒక ఆబ్జెక్ట్ ఉంచినప్పుడు వాటి నుంచి వచ్చేటువంటి ఇన్సిడెంట్ రేస్ ఏవైతే ఉంటాయో అవి ఎట్లా రిఫ్లెక్ట్ అవుతాయన్నది మనం రే డయాగ్రామ్ ద్వారా చూపించడం అండ్ ఆల్సో ఇమేజ్ అనేది ఆ ఆబ్జెక్ట్ యొక్క ఇమేజ్ అనేది ఎలా ఫామ్ అవుతుంది అనేది కూడా మనము ఈ వీడియోలో తెలుసుకుందాం. దిస్ ఇస్ ఓన్లీ ఫర్ ద కాన్కేవ్ మిర్రర్. ఓకే, ఎందుకంటే బిఫోర్ ద వీడియో వీ హ్యావ్ డిస్కస్డ్ అబౌట్ ద రూల్స్ అబౌట్ ద కాన్కేవ్ మిర్రర్ ఓన్లీ, అండ్ అకార్డింగ్ టు దట్ రూల్స్ we are using the rules and we are discussing and draw the ray diagrams, the objects which is situated in different various places before the concave mirror, and how to form the image, what are the characteristics of image. Okay, so here before the concave mirror on the principal axis we situated the object in different places. In the first place is at infinity. Infinity means an object will very far from the concave mirror. Infinity means an object situated on the principal axis is very far from the this concave mirror, so that is called here infinity. Okay, infinity means so long that is not measured a particular very hard to measure to in between of concave mirror and object, so that is called infinity. So when you assume an object will situated so far from the concave mirror at infinity place on the principal axis, generally we can assume the rays will come to the parallel of the axis, to parallel of the axis from the object, and it meets a parallel light rays will meet the concave mirror in different 2 points, and it will always go through the focal point. It is a rule number 1. So according to the rule number 1, all the light rays are travels from the object which is parallel to the principal axis and meet the focal point. Here when you place the screen to this point, at this point, focal point, so you can catch the image on the screen, but the image is very diminished. That is called very diminished means very pointed image you will observe on the screen. Okay, so this situation is when an object is so far, which is at infinity, and it will form the image at focal point very diminished, that is called pointed image. Okay, so this is the first situation. So pointed image will form when an object situated at infinity place before the concave mirror. అంటే చాలా దూరంలో ఉన్నటువంటి అనంత దూరంలో ఉన్నటువంటి ఒక వస్తువు నుంచి వచ్చే లైట్ రేస్ ఈ ఫోకల్ పాయింట్ దగ్గర చాలా చిన్నగా పాయింటెడ్గా ప్రతిబింబాన్ని ఇమేజ్ని ఏర్పరుస్తుంది. సో దిస్ ఇస్ అ వెరీ క్యారెక్టరిస్టిక్స్ ఆఫ్ ఆబ్జెక్ట్. ఓకే, సో ఇమేజ్ యొక్క క్యారెక్టరిస్టిక్ ఏంటి ఇక్కడ? పాయింటెడ్ ఇమేజ్ ఓన్లీ. ఎప్పుడు? సో వెన్ ద ఆబ్జెక్ట్ ఈస్ వెరీ ఫార్, వెరీ అట్ ఇన్ఫినిటీ to before the concave mirror. So this is the first situation. Okay, now we will go to second situation. Children, this is the second situation, that is beyond C, when the object situated before the concave mirror on the principal axis, when beyond C, అంటే C అవతల కనుక it is beyond C means the first situation, first case is also beyond C, but it is at infinity. Why you say that is infinity? It is very hard to calculate it, the distance before in between of concave mirror and the object. Now you can say this B and C, it means you can measure very easily to the pole of the point of this concave mirror and the image, and the object. Okay, so that's why we can say this is a B and C. When an object is situated beyond the C on the principal axis before the concave mirror, so here I'll take the two incident rays from the object, tip of the object here. So the first one is, it is a parallel ray. Okay, it's a parallel to the axis from the tip of the object, and it will act, it's go through, always reflected through the focal point. So focus point I will draw like this. Okay, so this is the rule number 1 also. And the second ray, incident ray, also coming from the tip of the object, is go through the focal point and meet the concave mirror, and it reflected as a parallel to the axis. So this is the second rule, according to the second rule. Now you can see, observe here in the diagram, these two reflected rays will meet at a point in between of F and C. So here the image will form of actual object. So here, so what is the characteristics of this image? You will see here, it is inverted, and it is in between, it forms in between of F and C, and it is diminished actual to compare the actual object. And also we can catch this image on the screen, so that's why you can say this is a real image. Okay, so see, అవతల వస్తువు ఉంటే ఈ కంప్లీట్ డయాగ్రామ్ ప్రకారం ఇమేజ్ అనేది ఎఫ్ఎన్సి దగ్గర ఫామ్ అవుతుంది. ఇది తలక్రిందులుగా ఉంది, అలాగే యాక్చువల్ ఆబ్జెక్ట్ కన్నా చిన్నగా ఉంది. అలాగే ఇక్కడ స్క్రీన్ కనుక మీరు ఉంచితే, స్క్రీన్ కనుక ఇక్కడ ఉంచితే ఈ ఇమేజ్ అనేది ఈ స్క్రీన్ మీద మనం క్యాచ్ చేయొచ్చు. దట్స్ వై యూ కెన్ సే దిస్ అ రియల్ ఇమేజ్. So these are the characteristics of image. That's why there are 4 characteristics of this actual image, that is inverted, and the image formed between F and C, and it is diminished actual object, and you can catch the image on the screen. That's why you can say this is the real image when the object is beyond the C on the principal axis before the concave mirror. So this is the second situation, second case. Okay, see children, this is the third case, when the object is situated at the point of C. At the point of C means on the C. Okay, C means center of curvature. When you situated the object on the C, center of curvature, at the point of C, again I will take these two incident rays, so tip of the object. When the first ray will goes parallel to the principal axis, and it acts like it reflected through the focal point, and the second ray will comes from the tip of the object and go through the focal point and touches the mirror, and it reflected as a parallel to the principal axis. These two reflected rays meet at the point here. See here, so the tip of the two rays will meet, reflected rays meet at this point, and the image will form at this point. Okay, so you will observe and concluded that the image is inverted, right? Again, where the image formed here, exactly on the C, at the curvature point. Okay, on the C, on the curvature point. And what is the size here? It is not diminished. Okay, so it is not diminished, and it is not big size to compare the object. It is very equal size to the object, and you can catch the image when you place the screen on this point. You will catch the image. So that's why you can say this is a real image. Okay, so children's, కర్వేచర్ పాయింట్ దగ్గర సి దగ్గర మనం ఉంచితే ఈ రెండు రిఫ్లెక్టెడ్ రేస్ ఇక్కడే ఈ పాయింట్లో మీట్ అవుతాయి. ఈ పాయింట్ ఎక్కడ ఉంది? సో ఎగ్జాక్ట్లీ ఎట్ ద కర్వేచర్ ఆఫ్ ద పాయింట్. ఓకే, సో సెంటర్ ఆఫ్ కర్వేచర్. సో అందుకే మనము ఈక్వల్ సైజులో మనకు ఇమేజ్ అనేది ఏర్పడుతుంది. సో ఇప్పుడు దీని యొక్క 4 క్యారెక్టరిస్టిక్స్ ఏంటి? సో ఇట్ ఈస్ ఇన్వర్టెడ్, and second point is, second characteristic is on the C at the center of curvature, and third one is the same size, it's the equal size of the object, the image is the equal size to the object, and fourth one is you can catch the image, that's why it's a real image. Okay, so the fourth character is the real image. Okay, so this is the fourth situation. When your object is situated in between F and C, so what are the characteristics of image? You will see the diagram of this concave mirror. I draw an object in between F and C, and the two light rays draws here. At the tip of the object, the first light ray will go parallel to the axis, and it reflected go through the focus point, and like this. Okay, and the second light ray tip of the object and go through the focal point and meet the concave mirror, and always it reflected as a parallel to the axis. Here you observe these two reflected rays will meet at this point. So where it is situated, this point here, to compare this axis, it is beyond the C. Okay, it is beyond the C, so that's why you will say the image is also formed at beyond C, and the image is inverted. Okay, so the image is inverted and it formed beyond C, and you will compare the size of the image to compare the object, it is larger than the a real object. Okay, and always you situated a screen here, and you can catch the image on the screen, so that's why you can say the image is real image. So this is the ray diagram of an object in between F and C and the image. Okay, so here the four characteristics of this image. When the object is in between F and C, the image is inverted, తలక్రిందులుగా ఉంది, and it is situated always in the beyond C. C అవతలనే ఏర్పడ్డది, and it's always larger size to compare the object, పెద్దదిగానే ఉంది, and you can catch on the screen, that's why you can say it's a real image. ఇది మనం రియల్ ఇమేజ్ అని అంటాం. So these are the characteristics when an object before the concave mirror situated in between F and C. Okay, so these are the four characters. Situations. This is the fifth situation. When an object is situated at point of F, on the F. Okay, so focal point మీద మనం కనుక ఆబ్జెక్ట్ని కనుక ఉంచితే at F, at focal point. So here I draw an object at focal point F, and as usually we can take two incident rays tip of the object, but here in this situation the first incident ray is travels from to compare the axis to parallel. Okay, but the second before diagram we can take a ray diagram in the incident ray will go through the focal point, but in this situation we cannot take the go through the focal point. Why? Because an object is situated on the focal point, so that's why we can take the third rule. That is, the third rule means a light ray will go through the center of curvature. Okay, so this is rule number 3 we can take here. Okay, so the first incident ray, you see here travels parallel to the axis and go through the focal point like this here. And the rule number 3, that means a second ray I will take here. When a ray will go through the center of curvature to tip of this object and to meet the mirror, and it will come back in the same path. So that's why we can take here like draw like a here like this. Okay, so these two rays you observe very closely. When these two reflected rays will meet at beyond the C at any point. Okay, but so far to compare beyond the sea, so far very to meet these two reflected rays to compare the axis. Okay, so here the two reflected rays will meet, must and should, but it is very large and very far to the concave mirror. Okay, so that's why we can observe this image will form beyond the sea, so far from the concave mirror, and it is inverted. As usually it is inverted, and the object of the image is very larger to compare the object, and you will placed at the two reflected points is connected at meet a point. You will place the screen, you can catch the real image also. Okay, so that's why we can say the four characteristics of the image when the object is placed on the uh, uh, f focal point. So the image always it will be inverted, and the image formed beyond C, and it is always larger than to compare the real object. And you can catch the image when you placed a screen these two reflected rays to meet at point. Okay, so these are the four characteristics. So this is inverted and beyond C, and it is very larger, and you can catch the image that is a real image. Okay, see this children's, it is a loss situation when an object is placed between P and F. P means pole, F means the focus point. So when an object is placed in between P and F on the axis before the concave mirror, how it form the image, you will see this diagram. So here a tip of the object will I will take two incident rays. One is a parallel to the axis. It cannot be take a focal point incident ray. I will take the third rule, which it means tip of the object incident ray will go through the center of curvature. Okay, you observe first incident ray will travels parallel to the axis and go through the focal point like this. Okay, the second incident ray will go through the center of curvature of this concave mirror and meet the mirror, and it will go back in the same way. Okay, so you observe these two reflected rays are not meet at any point beyond the sea. Here you can see this. So there is a distance where these two reflected rays will go to very far to the mirror. Here the two reflected rays will not meet at any point here, but you can observe these two rays will come at some point of inside of the mirror. Okay, so when you draw these two incident rays, two reflected rays inside the concave mirror in a dotted line, so these two dotted lines will meet here inside the concave mirror. So at this point these two reflected rays will come, you assume. Okay, so here these two dotted lines will meet here, and object also form in the inside of the concave mirror. So that's why we cannot catch this image on the screen. So it is a virtual image. So what are the characteristics you will observe here? So the image is not inverted, it is erected size. Actual is a erected object, it's erected size, not inverted. Okay, that is the first character. So the image when the object is in between P and F before the concave mirror, the image is not inverted, it is erected. Okay, this is the first character. And the second character is always this image is inside in between F and P, in between F and P. So that's why the second character is always the image formed in between F and P. So you can observe here the object is in P and F, and the image is also inside of the F. Okay, in between of F and P, and it is very larger to compare the object, and you cannot catch this image on the screen. You can see only this image inside the concave mirror. So that's why it's a it's not a real image, it's a virtual image. Okay, it's a virtual. So this kind of principle is to use in made of microscope. When microbes, you can see the microbes with the microscope, you can place the microscope very near to the microbes. So that's why you can observe the microbes is a erected size and very bigger than the actual size of the microbes. Okay, so that's why we can use this principle, and you can use this concave mirror like this principle to made by the made to the microscope. Okay, so this is very important diagram of your examination. Okay, so these are the 6 situations before the concave mirror. The object is placed in various places, and the ray diagrams of images and characteristics of images. Okay, are you understand, children? Okay, good.